We're going to discuss ensemble models. One such ensemble model is random forest. Let us see what exactly is this ensemble model and how is it different from the rest of the models. Now, there is a concept called wisdom of crowds. Knowingly, unknowingly, everybody in the classroom, you and me, we all follow this approach of wisdom of crowds. For example, you want to buy a mobile phone. You have to order it on Amazon or Flipkart. You decided that you're going to buy a mobile phone. You have decided on a budget. I want to buy a mobile phone around 25,000. You have decided on what should be the RAM, what should be the screen size, what should be the camera. You have decided on all the specifications, what should be the battery, etc., etc. Now you search on Amazon. There are 6 smartphones that are satisfying all the conditions. 6 smartphones, exactly 6 smartphones. All of them have the same price range. All of them have the same batteries. All these 6 smartphones have exactly the same specifications that you are giving. All of them are from good companies. Okay. Obviously, you're not going to order 6 smartphones. You're going to buy only one out of those 6. Which one is that you're going to buy out of these 6? How do you decide that in general? Don't think from data science point of view. In general, tell me, how do you find that one phone that you're going to order?
Based on the ratings and reviews.
Based on the ratings and reviews, you will go for that particular smartphone that has the highest ratings and highest reviews. If everybody is saying this is a good phone, go for it, you tend to go for it, isn't it? That's what I follow, that's what you follow. If everybody is saying this is a good phone, we tend to buy it. That is known as, that particular concept that we follow, that is known as wisdom of crowds. What is wisdom of crowds in general that we follow? One should not expend energy in trying to identify an expert within a group. You will not go to a mobile expert or mobile engineering expert, ask him which phone I should buy. No, you don't do that. Instead, you rely on group's collective wisdom. A group of smart people, if most of them are saying that go for it, we tend to go for it. That is known as wisdom of crowds. Now, if you connect that wisdom of crowds to our machine learning approach here, now it will convert to this. Let us take this example, a different example. Imagine you have a problem statement. We want to estimate what is the monthly expense of a family in our city. Let's say in a city, New York or somewhere, we want to find out what is the estimated monthly expense of a family. Now you have 2 scenarios. In scenario 1, you gave this problem statement to an eminent professor, wonderful professor from a big university. He is a great data scientist. He builds one model. He gives you a predicted value. The estimated monthly expense of a family in our city is $6,500. This is a prediction from one model. In scenario 2, you take the same problem statement, go to 100 assistant professors. Give the same problem statement. All these 100 assistant professors are good data scientists. But if you compare them individually to this professor, they may not be as good as the eminent professor. However, these are all good data scientists. Each one of them built their own model. Each one of them gave their own prediction. Somebody told that $6,800. Somebody told that $7,500. Somebody predicted that it will be $6,300. Everybody gave their own prediction, $7,000, $7,300, like that. These 100 assistant professors built 100 models, came up with 100 predictions, and you take the average of all these 100 model predictions. The average comes to be $7,200. Single predicted model, $6,500. Average of 100 models is $7,200. Now, if I give you a chance, if I ask you to pick up one out of these two, which one has higher chance to be near to the accurate prediction? Which one has higher chance to be the accurate prediction? Tell me in general.
S2.
Scenario 1, where one
One.
professor built model, or scenario 2, 100 professors, their average, which one has maximum chance to be near to the actual one? What happens is, in
The
real
model.
life, there are so many experiments done. Most often, this average of 100 models, that has very high chance to be near to the actual value. Instead of building one model, making the prediction from that, you build hundreds of model, take their prediction, average of prediction, then you take that final value that will have higher chance to be near to the actual value. That is known as ensemble learning. Ensemble learning. Whenever you hear this term ensemble, you have to imagine that we are building multiple models. What's the approach that we have followed until now? We have the data, we built a model, and when the new data comes, we got the predicted value. But from here on, we are going to change the approach. We have the data, we build model 1, model 2, model 3, model 4, and so on, model 100, hundreds of models. Model 1 has this much accuracy, model 2 has this much accuracy, model 3 has this much accuracy, model 100 has this much accuracy. Once the new data comes in, every model will give its own prediction here. For one new data point, you will have 100 predictions. But the thing is, for one data point, you have to make one prediction only. What do you mean by one prediction? One new customer, whether he will be a bad customer or a good customer. One prediction you have to make, but you have 100 predictions. Let us suppose out of these 100 models, 95 models are saying -1 is a prediction. 5 models are saying +1 is a prediction. What will be that one final predicted value?
-1.
-1 because most of the models are saying -1 is a predicted value. This approach is known as ensemble model building. These are known as ensemble models. What do you mean by those ensemble models? You have the data. Instead of building one model, you build model M1, model M2, model M3, model M4, and so on, model MK, and then take the predictions from each of the model. If it is a problem statement of regression, you collate all those predictions by taking the average. If it is a problem statement of classification, how do you find that one value as a prediction? Because 100 models will give you 100 predictions. How do you collate all of them to one prediction? Think of it. Like every model will give you one class as a predicted value. How do you
So the
come up?
class
The
that has been
class,
predicted more times.
the class that has been predicted by most of the models or more times, that will be the one that is predicted as the final predicted value. This is just a philosophy of ensemble models, just an intuition that I'm giving you. But there is a particular approach that we follow in ensemble model that is known as bagging. This is the actual ensemble model that we have to learn. Until now, whatever we discussed, that is just a kind of introduction only, just to give you a flavor of what exactly is ensemble model, just the philosophy of it. The actual ensemble model building technique is bagging, comes from two words: bootstrap sampling, aggregation of learners. Bootstrap, aggregating, bagging. Bagging has these two parts. The first part is bootstrap sampling. Let me explain you what exactly is bootstrap sampling. It's kind of, until now, it's kind of general theory only. I feel you're following me. By chance, if you have any questions, please let me know before we proceed further. Good to go? Yeah. Look at this. Imagine you have a data set with 10 records. You have this data size is 10. This is your original data. A data set with 10 records. That means if you take the record IDs, record number 1, record number 2, record number 3, 4, you have 10 records and you have some columns, 5, 6 columns, or how many ever columns you have. This is the original data that you have with you. Okay. Usually, if you take a sample, if the sample size is also 10, you take a sample, if the sample size is also 10, what will be that sample? There is a data set with size 10. If I take a sample of size 10, what will be that sample? Can I say that sample will be almost same as the data set? Yes or no?
Yes, sir.
If we try that, if we have a data set with 10 records, if we take a sample of 10 records, then sample will be same as the data. However, bootstrap sample is very different. Bootstrap sample, the sample size is 10 only in bootstrap sample. But the way we pick that bootstrap sample, the way we create that bootstrap sample is very different. You want to pick up a sample of 10 records from the original data. This is how you do it. First, you pick up a record, randomly one record between these 10 records. Like first record or second record, or randomly any of these 10 records you can pick. So I have picked 3. Now you go to the second record. Again, randomly pick one record between 1 to 10. Again, between 1 to 10. So this is the second sample, third sample. Like that, you repeat it 10 times. You repeat this procedure of picking only one record randomly 10 times. If you repeat that, that will be bootstrap sample 1. Similarly, you can bring bootstrap sample 2. This is also known as bag 1, bag 2, bag 3, bag 4. Any number of bootstrap samples you can take. Is it a fair point to say inside a bootstrap sample, there can be some repetitions, duplication is possible inside a bootstrap sample?
Yes.
Is it
Yes,
a
sir.
fair point if I say inside a bootstrap sample, there can be some records that are never picked up? If you go here, record number 2 was never picked up. But if you come here, record number 2 multiplied multiple times, it has been picked up. Inside a single bootstrap sample, there are some records that are repeated multiple times. If you go to a different bootstrap sample, the record that was missing here may be repeated multiple times. This is bootstrap sample 1, bag 1, bootstrap sample 2, bag 2, bag 3, bag 4. Bootstrap sampling is almost like sample with repetition. Some of the records may repeat. That's what bootstrap sample is. Based on that, bagging is formed. Now, here is the theory of bagging. Here is the bagging algorithm. Very simple algorithm. Imagine you have a data site. Size is, let's say, 10,000 records are there. These are 10,000 rows. And T columns are there. The number of columns in the data set, let's say 25 columns are there. You make 1, 2, 3, 4, and so on, K, 100, 150, 200, these many bootstrap samples, where K equal to hundreds or 200s or 300s, like that. Several bootstrap samples you will make. What will be the size of each bootstrap sample or each bag? How many records will be there here in this bag? The number of records in each bag will be how many?
10,000.
10,000.
Whatever is the size of the data, the same. Here n is 10,000, so there will be n records here, n records here, n. Does that mean this is exact replica of the data? Here
No,
10,000
sir.
records are there, here 10,000 records are there. Is just a replica of the data?
No.
No. There are some records that are repeated multiple times. There are some records that are ignored. There are some records that are repeated multiple times. There are some records that are ignored. So you have a data set, you have a bootstrap sample or a bag. On each of the bag, you build a model. Model M1 on this one, M2 on this one, M3, etc., etc. You build a model on each of the bag. The model building technique is same. If this is regression, everywhere it is regression. If this is regression, everywhere it is regression. If it is logistic regression, everywhere it is logistic regression. Everywhere it is logistic regression. If this is decision trees, everywhere it is decision trees. All right. So the model building technique is same. Once these models are built, at the time of prediction, that means this model building is done, this ensemble model building is done. Once the new data point comes, every model will give its own prediction. 100 models are there, 100 predictions you will get. Then collation happens. How do you collate? If it is a regression type of problem, to give one predicted value, how do you collate all these 100 predictions? Think of it.
By taking the mean.
By taking the average of all these 100 predictions. If it is a classification problem, how do you collate all these 100 predictions?
We will go by the frequency of the class
The
predicted.
class that has been predicted by maximum number of models, that will be, or based on the frequency. Let us suppose 100 models are there, 75 of them are predicting as +1, 25 of them are predicting as -1. I would rather say the predicted value is, or predicted class is, +1. That is known as a bagging algorithm. When you compare this bagging algorithm to a simple model like regression, logistic regression, or decision trees, bagging algorithm, these type of bagging models, they tend to give minimum 2 to 3% lift in the accuracy. Minimum 2 to 3% lift. If we are lucky, sometimes even we may see 5% improvement in the accuracy. That means, let's say if decision tree is giving max to max, I can achieve 88% accuracy only with the same data, without any modifications, without any extra effort. Just by changing the algorithm to bagging, you can sometimes push it to 90% or 91%. Already these are powerful algorithms. On top of them, without putting a lot of effort on the data, without spending a lot of money on the data, you will be improving the accuracy. There was a couple of questions that I have a lesser accuracy when I tried regression or logistration or decision tree. Is there a way to improve it? One of the ways is try bagging technique, try ensemble models. They will take the data, they will try to squeeze in every bit of information by building multiple models and repeating the data points at some places so that none of the patterns will be lost. We will do our best to capture every inch of the pattern and then try to improve the accuracy. This is known as bagging algorithm. However, bagging algorithm is also not used by a lot of data scientists. There is a special case of bagging that is used in the actual industry. In bagging algorithm, you can build any model here. Instead of building any model, if you're building a specific model, let's say if you're building only decision tree everywhere, then bagging algorithm will be called as, since several trees, what do several trees do? If you have several trees, they form a forest. So if you are building only decision tree inside bagging, this algorithm will be called as random forest. So what is random forest? Random forest is a special case of bagging. Do you agree with that? Random forest is a special case of bagging. What do you mean by that? It's not a new algorithm which is entirely different from the original philosophy of bagging. Here is the random forest algorithm. Imagine you have a data set of size n. Let's say 10,000 records are there. Imagine you have around t columns. Let's say t equal to 25 columns, 10,000 rows. You take this data, make k bootstrap samples or k bags. Usually k is a large number, hundreds, 200s, 300s of bags you will make. What will be the size of each bag once again? The size of
10,000.
each bag is 10,000, 10,000. Here it is 10,000. In general, it is n. Whatever is the size of your data, that will be the size of each bag. On each bag, you build a model. What kind of model are we going to build? Since it is random forest algorithm, we are specifically building decision tree. Everywhere you're building a decision tree model. That is it. Once you build that model, model building is done. Random forest is completed. Now one new data point comes. You have to make a prediction. That means a new customer has come. You have to predict whether he is going to be a good customer or bad customer before giving a loan. But for one customer, you will get how many predictions here? Are you going to get one prediction if you send it to random forest? You're going to get
100, sir.
hundreds of predictions. Then we have to collate all of them to give single prediction. How does the collation happen? Let's say out of 100 models, if around 80 models are saying the customer is bad customer, around 20 models are saying the customer is good customer, we will say there's a high chance that the customer is bad customer. That is the random forest algorithm compared to a simple model like logistic regression or a decision tree model. Universally, if you try random forest with the same data without making any modifications to the data, random forest is so powerful in squeezing every pattern that is available. Random forest tends to give you 2 to 3% lift in the accuracy. Sometimes the lift can be even 4%, 5%. Okay. That is the actual algorithm of random forest. Before I proceed to the next point, let's pause here and take a couple of questions. Anything that is not clear that need to be addressed quickly, let me know.
Sir, will bagging give us the overall accuracy or class-wise accuracy?
Tell me, think about it. You have y actual values, right? You will get y predicted values. Yes or no?
Yes, sir.
Then you'll get confusion matrix. Yes or no?
Yes, sir.
Yeah, now think and tell me. So let me draw the confusion matrix for you. 0, 1 will be there. 0, 1 will be there. Tell me. Can you find overall accuracy?
That means we can even find sensitivity and specificity after this.
Exactly. Does the algorithm really matter what you're finding? Think of it. Does the algorithm matter?
No,
What
sir.
does algorithm give? Does it give confusion matrix to you or it gives you predicted values? Does the algorithm give us confusion matrix, sensitivity, accuracy, recall, precision, F1 score, AUC, ROEC? Does the algorithm give that?
No, sir.
What does the algorithm give at the result?
The predicted values.
Predicted value. Based on the predicted value, you can actually create a plethora of those metrics. Yes, sir. Now answer
Yes,
your
sir.
question. Does the bagging give us overall accuracy or class-wise accuracy?
Sir, both.
It can give anything, depends on what we are calculating, isn't it? Make sense?
Yes, sir.
So my short answer to that is it gives you predicted values. Now it's in our hand what we are calculating out of it. Okay. Carry on with any other thought-provoking questions.
Sir, I have a question.
Yeah, please go ahead, Jagannath.
If the model is a logistic regression one, then it's fine. We can taking the average of multiple decisions, or we can taking average of the multiple values that we have. But while building number of decision trees, there will be number of rules.
Right.
On that case, how to achieve the final segmentation?
Here, the result of the random forest doesn't give you segments. This decision tree will give you rules, right? Let's say it gives you 15 rules. Now, one data point comes out of those 15 rules, it will give you a predicted value only. You run one data point through those rules, it will finally end up with either customer is 0 or 1. Yes or no? So like that, you treat all these decision trees and run that data point through all these decision trees. Every decision tree will come up with a predicted value. After that, you're collating them. You're not combining all these rules to make a bigger pool of rules. Okay. You're taking prediction. After that, the collation is happening. Now, what happened was, in theory, random forest is supposed to give 2 to 3% lift in the accuracy when you compare it to a decision tree. Now, when data scientists started using this on practical data sets, on real data sets with thousands and thousands of rows, tens of columns, or maybe hundreds of columns, what they have observed is, very strangely, random forest, even though it is so much complex, even though it is time consuming, even though hundreds of models we are building, with all these extra effort also, random forest is giving actually less accuracy than decision tree on practical data sets. A single decision tree was giving 2 to 3% more lift than a random forest where hundreds of decision trees are built. Then the data scientists got shocked. How come hundreds of decision trees are giving together overall accuracy is less than a single decision tree. Then people started investigating. In the investigation, this was found. What was found? Yes, this is a bag. This is a Bootstrap sample where some records are repeated here, some records are ignored. But in terms of information, it carries the complete information about the data. The records that are ignored, maybe they are not that much valuable. That means every row is not a piece of information for you. Yes or no? Customer 1 whose age is 75, customer 2 whose age is also 75. These are two data points, but are there two different patterns for the model? We cannot say that every data point is coming up with a new pattern, isn't it? So what has happened was this particular Bootstrap sample is carrying almost all the information from the data. This particular Bootstrap sample is carrying almost all the information. Yes, it is true that some records are repeated. Yes, it is true that some records are ignored. But in terms of information, almost every Bootstrap sample, every bag was carrying complete information. Because of that, this decision tree is almost equivalent to this one. This one is almost equivalent. Almost. What do you mean by almost equivalent? If you have 15 rules, almost 14 are matching. Almost 14 are matching. Almost it's a single decision tree repeated 100 times. Do you think repeating the same decision tree 100 times is going to improve your accuracy overall?
No.
Imagine that single professor versus 100 assistant professors. Why did you pick 100 assistant professors? Their prediction will be better. You thought that they are building 100 different models. Yes or no? That's why you told that 100 assistant professors model is better. But what if I tell you all these 100 guys are sitting inside one room? What if I tell you all of them are discussing among themselves? What if I tell you they built one model, but they submitted it 100 times? Do you think building one model, submitting it 100 times going to improve the accuracy? Is that going to work? Somehow these models need to be independent. Yes or no? Somehow we have to make all these models independent. This decision tree has to learn some patterns which are independent of this decision tree. This has to learn some patterns that are independent of this decision tree. All these decision trees must be independent. Now, how do you make those decision trees independent? Now, here is the extra condition that has been added to make these models independent. Now, what is that extra condition? While you are building this decision tree, let's say if you have T columns here, 25 columns, do not use all those T columns to build this decision tree. Use only P columns where P is much, much less than T. What do you mean by that? If you have 25 columns here, use only 5 columns while building this decision tree. P equal to 5 here. P equal to 5, where T equal to 25 overall. You have 25 columns, you're only using 5 out of them for building this model. Randomly picked 5 columns for building this, randomly picked 5 columns, randomly picked 5 columns. Wherever you are building this decision tree, individually you randomly pick only P number of columns from the overall data of T columns. What that will do is this decision tree will learn something independent of this one. This will learn something independent of this one. All these decision trees will be totally independent. Now, with that extra condition, once you make the decision trees independent, now it is universally proven, no matter what data that you take, no matter what application that you take, no matter how many variables are there. Now, random forest, universally, it gives 2 to 3% lift in the accuracy. Practically, theoretically, it is now proven that random forest gives you better accuracy with this extra condition. So once again, what is the random forest algorithm? Imagine you have a data set of n rows and T columns. Make K bootstrap samples or K bags, bag 1, bag 2, bag 3, and so on, bag K. K number of bags are there. K is usually a large number, hundreds of bags. Okay. On each of the bag, inside each of the bag, how many records are there? The number of records are same as the data set size. On each of the bag, you build a decision tree model. But while building the decision tree model, do not use all the T columns. Use only P columns where P is much, much less than T. Not just less than, much, much less than T. Use only P columns, build a decision tree, use only P columns, randomly pick P. Let's say, for example, here out of 25, you pick only 5 columns. Okay. Out of the 25 columns. Then build the decision tree. Once you have these decision tree, collate these results. That is the random forest algorithm. However, while building the random forest algorithm, there are some hyperparameters that are in your hand. Okay. Those are hyperparameters need to be set accurately. Then only random forest will give you better accuracy than decision tree. So what is the first hyperparameter which is in your hand that you need to set accurately? The first hyperparameter that is in your hand is number of trees K. Number of trees K. K must be a large number. What happens, let's say in this example, what if I choose K equal to 3? I'm building 1, 2, 3 trees only. Can you tell me what will happen in the same example? If I choose K as a very small number, what is the risk?
Shortage of data.
If I choose k as a very small number, maybe you will pick 5 records here, five columns here, 5 columns here, 5 columns here. Max to max, how many columns you will consider for model building? Max to max? Out of 25,
15.
max to max 15 only. Do you think considering only 15 out of 25 is going to give you great accuracy? If your k is very less number, what will happen automatically? Are you going to get an error that you cannot build the model, or the model will be built? Think of it.
So the model will be
The
built.
model will be built, but what will be the problem with that model? What will be the result? What will be the issue with the result? You're not even using full data that is given to you. If you don't even use the full data that is given to you, the model will be obviously underfitted, isn't it? There is a scope for improvement, but you're not utilizing the full data. You're not learning all the patterns. Okay. So the number of trees k has to be a very large number in general. If you have absolutely no idea, then choose k as maybe start with 50, then 75, 100, 200, 300. Choose that as the number. Number of trees k has to be a very large number. It cannot be a small number. If it is a small number, there will be loss of data. If there's a lot of loss of data, then you will not be able to build the good model that is finding out all the patterns. Okay. Is this trick clear, all of you? The lower limit only defined, upper limit can be anything. For example, you need 60 trees. In place of that, if you build 80 trees or 100 trees, that's not a problem. But if you go much below 60 trees, if you're building only 30 trees, then you have an issue. You will have an underfitted model. Random forest will not give good accuracy. The second hyperparameter that is in your hand is that you can choose while building the model is number of features denoted by, you can choose the number of features denoted by in this algorithm. What are we denoting that as? With the letter P. Number of features P. I'll tell you the mistake that a lot of data scientists do. What is the mistake? It's a mistake with a good intention only. What is it? I want to build the best decision tree here. This has to be best one. So I'll choose P as 24 out of 25. I want to build this one to be best one, 24 out of 25, 24 out of 25, 24 out of 25. Everywhere I'm picking 24, 24, 24 out of 25 columns. What happens if P is a very large number, almost equivalent to T? What happens in that case?
So there will not be a significant lift in the accuracy.
What will happen? Think of it once again. What was the original issue with random forest that was faced by the data scientists when they first used it?
Chances of redundant trees.
What will happen is, what was the first issue? Since we are picking 24 out of 25, here also 24 out of 25, almost all these trees will be identical. You will be building the same tree, almost all the rules will be same. If almost all the trees are identical, is it going to improve the accuracy? It is almost like building one model, counting it 100 times. That's not going to improve anything. That is why the number of features P has to be a very small number. A general ballpark number is choose P somewhere around square root of T. That means if you have 25 columns, what should be the P value that you should pick?
5.
5, 6, 7. That range you have to pick. Let's say if you have 100 columns in your data set, some of you have 50 columns. If you have 50 columns, what is the number P that you will be picking?
9 or 10.
9, or like if you have 50, square root of 50 is how much?
7.
8, 9, something like that. Okay. Somewhere around square root of T is what you have to pick for the number of features. This has to be very large number of trees so that we do not miss any data. This has to be relatively very smaller so that we can achieve independence. If you set T accurately, if you set P accurately, then definitely random forest will give you better accuracy than decision tree. Finding optimal K, finding optimal P is not very difficult. It is not difficult because the optimal value is not just one value. It's a range of values. You just need to be near to that range. Once you're somewhere in that range, you will be able to get a better random forest model. In fact, in our exercise, we're going to see how do we actually fine tune this K, fine tune this P. That is the random forest algorithm. It is all theory that we have discussed until now. Once we do an exercise on this, a practical example, then only we will understand some more nuances in that. Before getting into that case study, let me know if you have any questions here. Are you ready for the case study? All right. This is one of the old video that has been shared by Volvo. What are they trying to demonstrate here? The driver
Crash
who's
testing.
the driver who's sitting in that truck, he's not applying the brakes. Actually, they're not displaying crash testing here. What they're displaying is
Yes.
as soon as as soon as this truck is approaching an obstacle, it is about to hit, automatically the speed will be reduced, automatically the brakes are getting applied. There are several sensors that are attached to this truck. As soon as it reaches near to this vehicle, then there will be an alert system. Look at this, there is an alert system that is working. Once you can generate an alert, you can almost do anything out of it. Right now in India also, these kind of systems started coming in the name of ADAS, where you will be able to reduce the fatality of the accident. If not exact accident, at least you can reduce the fatality of the accident. We have luckily got the data for this. This was shared by Ford company. You know what Ford company has done? In around 40 lakh cars, in 4 million vehicles, most of them were cabs, they have arranged some sensors. These sensors are small devices. I think you may have seen car parking sensors at least, isn't it? A small device that will sense how
Yes.
much distance is there from the wall to your car. If you keep on approaching that wall, it starts beeping very loudly. Have you observed it, anybody? I think most of you must be knowing that.
Yes.
These sensors are very small devices. They will capture a particular information. There are several sensors in your smartwatch or smart band, isn't it? They track your blood pressure, they track your SpO2 level, isn't it? Some sensors will send light to find out the information. Some sensors will take sound as information. Nowadays, there are some light bulbs. As soon as you enter that area, then only that bulb will switch on. Otherwise, it will
Motion
switch off,
sensors.
isn't it? Motion sensors, sound sensors, light sensors, several sensors. So what Ford has done, they have kept all these sensors in around 40 lakh cars. Some 6 to 7 sensors they have kept that will continuously track vehicle environment related data in the vehicle's surrounding environment. What are all the details? How far is this vehicle from the behind vehicle? How far is it from here? In the vehicle's environment, in the outside, what is the temperature outside? One sensor will capture that. Is it raining? Is it snowy? Is it windy? One sensor will capture that. Like that, there are 7 sensors that will capture the vehicle environment related details. There are some other 7 sensors that will capture the vehicle related details, vehicle internal details. What is the speed of the vehicles? One sensor is, finding out that. Which gear you are in, one sensor is finding that. What is the engine temperature? One sensor is finding that. What is the gear shift rate? One sensor is finding that. In fact, if you look at some of the high-end cars, there will be a sensor in the car tire also. That means what is the air pressure in the car tire, whether it is going to deflate or inflate. That information is also continuously tracked. Next time, try to observe. There will be some sensors inside the car tire, especially for high-end vehicles. So vehicle-related information is tracked by some 7 sensors. There are some sensors that are tracking physiological data of the driver, whether the driver is sitting in relaxed position or upright position, whether the driver is sitting straight or is he looking sideways or is looking mobile phone, how many times he is blinking, whether he's sleeping or not, we can capture that also. Do you know that? Like whether the driver, whether he is like, if he's sleeping, that can also be captured with a sensor. Let's say it will keep on looking at your eyelid, and if that retina is not showing, then it will raise an alert. Like that, some 22 sensors they have installed in the cars. They sold all these vehicles, sold these 40 lakh vehicles. They waited for 1 year. Within 1 year, what will happen? Obviously, out of these 40 lakh vehicles, some vehicles, hundreds of vehicles or maybe thousands of vehicles have met with fatal accidents. That is natural, isn't it? Any vehicle will meet with an accident, but 40 lakh vehicles, not all of them will meet with accidents. Some of them met with fatal accidents. Now, what did they do? They started gathering the data. As soon as any of the car from this list comes to their garage, they will quickly connect that car to a laptop. Have you seen that nowadays? As soon as you take your car, they are connecting it to a laptop and checking where is the issue. IoT, isn't it? Same thing they have done. So as soon as a car comes with a fatal accident issue, now what are they doing? They connect it to a laptop, and just before the accident, sensor 1, sensor 2, sensor 3, and so on, sensor 22. What are all the details of these 22 sensors? Those details are captured. Just before the accident, these are the recordings. Car number 2, just before the accident, these are the recordings. Car number 3, just before the accident, these are the recordings. Car number 4, just before the accident, these are the. Car number 5, just before the accident, these are the details. Car number 6, just before the accident, these are the details. For all these cars that met with fatal accident, they have marked them as fatal 1. That means fatal accident. Now I have to get the zeros data. Isn't that easy to get zeros data? How do you get zeros data? You take your car, make sure that you go to the same place, make sure that you subject it to the same environment, make sure that there is no accident. You take the car to highway. These are all the sensor details when there is no accident. Take your car to the park. These are all the sensor details when there is no accident. These are all the sensor details when there is no accident. Basically, make sure that there is no accident. Take it to the same environment. Let's say if there's an accident in the rainy day, make sure that you take your car to a rainy day, record all the sensors, make sure that there is no accident. These are the sensor details related to no accident. These are the sensor details related to accident. So Ford has to invest that much infrastructure, that much money, that much time just to generate this data. Why can't we simply simulate the data in the computer lab? Can we do that? If you simulate the data in the computer lab, can you trust that model? Or do you need real data to get the real results? Tell me.
Real data.
Simulation can work and for video games only. Yes or no?
Yes.
For real data, with real data only, you can give real results. Because what happens in the real data, the roads are not as per your simulation. Like in the real data, you will get some challenges that you cannot simply think of. So that is why that much time, 1 year they have waited, and then that much money, like it's not easy, and then that much infrastructure, making sure that every garage has all this system of data gathering. They have to do this much just to get the data. Don't you think data is very much important when you want to do any machine learning model building? Isn't it? Data is the real key. Now I have the data. Now tell me one thing. You have two options. Either you can build a simple model, very simple model, like logistic regression or decision tree, which will give you slightly less accuracy, but you can build them quickly. Or you can build a very complex model, which takes a lot of computation power, like random forest, but definitely it will give you more accuracy. Now, which one do you think Ford will be preferring in this particular case?
The complex one.
Definitely, they don't care about simplicity of the model. Do they care about variable importance? Do they care about multicollinearity? Or what Ford will say? I don't care about anything else. I just want to give this as input. I want to get the output, but only one condition: the output has to be most accurate, isn't it? As much accurate as possible. Obviously, we will be going for a complex model. Isn't it the case where you are really, dying for that 2% or 3% lift? Isn't it? This is a place where we want as much high accuracy as possible. This is the story. You know what Ford has done? Ford ran a competition on this data. They made this data open source. They gave it to the world of data scientists, and they have run a contest on this data. Download our data, build the model. The best model wins the maximum prize money. That's what they told. Do you know any website where these type of data science contests are run? These type of data science contests are run on Kaggle. So this happens to be one of the Kaggle contest previously that was conducted. The challenge name was Ford Stay Alert Challenge Ford. You can go through the details. I have given you some details overview. So they have gathered physiological, environmental, vehicular data. Now we have to build a model, submit it here so that we will win all the prize money. Let us try to build this model. Have you understood the problem statement, all of you? Are you clear on what is the requirement here? In simple terms, sensors are the features. Fatal accident, non-fatal accident is going to be the target. I have one question before we get started with this. Already accident happened, right? Already accidents have happened. Then why are you building the model? What is the need? Jo hona tha already happened, right? It already happened. Why are you still building a model? What's the use?
To prevent further accidents.
in future.
So basically what do? We build a model on this data. Are we going to use on the historical cars? Are we going to go back to time and use it here? No. We will deploy this model where? Where do we deploy this model? We deploy it in new cars that will take all the sensors on the runtime, and then they will predict whether there is going to be an accident or no accident. If there's going to be an accident, then that will be sent as an alert to the automobile engineer. Then they will put some mechanism to prevent that exact deployment on the car. Maybe as a data scientist, you're not involved in that deployment, but at least as a data scientist, you are expected to take the input, give the prediction, so that the deployment team can take that prediction and take the necessary action out of it. Okay. So whole machine learning is based on this philosophy only. Understand the patterns from historical data, try to model them so that I can use it for future prediction. Okay. So let's go to the code file, get this data set. Give me the code file link, all of you. Anybody? If you have the code file link. Random forest. Yeah, here is the code file. All right. Import the packages. I have divided it into train and test. In general, if a single data set is given to you, have you already learned how to divide the data into train and test? What is the even need of dividing the data into train and test? Why can't I simply take the overall data, build a model on that? Why can't I simply do that? If you build the model on the overall data, there is no way you will be able to test whether that model is right or wrong. That's why you have to divide the data into train and test, build the model on train data, validate it on the test data. Then you look at the features, look at the X-train, Y-train data. What are the features here? Sensor 1, sensor 2, sensor 22. How many features are there? From sensor 1 to sensor 22. 22 features are there. Okay. Usually for this type of problem, we directly go for complex model, the model that will give you the maximum accuracy. However, first let us have a look at the simple model. Let us see a simple model like decision tree, how it performs. Generally, I suggest this because we will get to know what will be the accuracy, benchmark accuracy that we have to beat. That means if I'm building a random forest model, minimum how much accuracy should be there, that I should know. That's why let us start with the decision tree model and see what will be the accuracy that we will get. So go ahead, build a decision tree model. Tell me the train accuracy and test accuracy. How much is the train accuracy? How much is the test accuracy for this decision tree model that you are building? Accuracy on the train data happens to be 86%. Accuracy on the test data is 85%. This is already a decent model. But do you think if you are selling your car to a customer, if you say the accuracy of the prediction is 85%, do they really show confidence in us? Models like this, the customers want what, 99% accuracy, isn't it? They want accident prevention as much as possible. Okay. Decision tree uses all the T columns. How many columns are there? 22 columns are there, all the T features. And what is the final depth of the decision tree that you have worked with right now? Decision tree that you have built that has a depth of, how much is that? 6, is that right? Now let us build a random forest model. I'll give you a recap of what are the hyperparameters once again, then you can build. Pay attention, all of you here. Just confirm me once you're done with decision tree. Come to your message chat window, confirm it to me, then I'll explain these random forest hyperparameters once again. If anybody facing issue with the decision tree, let me know. All right. Look at this. When you're building random forest, there are some hyperparameters that you need to set correctly. Then only it will give you a better accuracy than decision tree. Otherwise, if you leave it to default, it may not give you good accuracy. What was the first hyperparameter in random forest that is in your hand that you need to set correctly? Can you recollect? What was the first hyperparameter?
Okay, so number of trees.
Number of trees, denoted by K. So number of trees K, when you are setting it up, it has to be a very large number or a very small number.
Large number.
As large as possible. Usually the range that we generally search is 50, 100, 200, 300 in that range. Is it okay to be larger than whatever is optimal? Can we have larger, even larger number? That is fine. Only lower limit is fixed. Upper limit can be anything. Generally, you try these numbers. What is the next hyperparameter? What is the next hyperparameter?
Features.
The number of features denoted by
P.
P. Yes. The number of features P is also in your hand. And usually this has to be a very large number or a very small number.
Very small number.
Usually a general ballpark number suggested by the data scientist. What is that?
Root of T.
Somewhere
Square
around
root.
square root of T.
T
T
value.
happens to be how much here? T is 22.
22.
Square root of 22. So in this case, what can you try as P in this particular problem statement? Something like 5, 6, 7. Okay. Square root of 22, surroundings of that. Is it true that P is precisely sharp point that you choose that, then only you will get right answer, or can there be multiple solutions for a single problem statement for these hyperparameters? Are these hyperparameters exactly pinpoint sharp number or their range of values? Usually what happens? Let's say if you go to a decision tree, the number of leaves, is that a pinpoint value or it's a range of values?
So pinpoint value.
Let's say if the number of leaves have to be exactly 12. If you go one below that, one above that, one below that, over underfitting will happen, one above that, overfitting will happen.
No,
Is
sir.
that are they pinpoint values or a range of values? Think about that.
Range.
Range of values, isn't it? The hyperparameters, we don't really need to worry about what if I give slightly lesser, what if I give slightly higher. Are you going to get a huge difference in that? Usually what happens is a certain range of values they will take. But if you're very far away from that range, then only you will see the danger. Okay. Now is P equal to 5 to 7? Is it universally the same number that we follow, no matter how many columns are there?
No, sir.
It depends on the number of columns. Then there's one more parameter that we need to set, that is max depth. This is the depth of every decision tree inside the random forest. Okay. Now it is impossible to go to, let's say if K equal to 300, isn't it impossible to go to each and every tree, start finding the optimal max depth? Theoretically, it is impossible, isn't it? What you need to do is you have to fix one depth for all the trees. Inside the random forest, you choose one depth for all the trees. Now the depth D suggested value is somewhat around 50% more than the single decision tree. Depth D is suggested to be 50% more than the single standalone decision tree. So in this case, D can be picked as 6 plus 50%. How much is that? Either 9 to 10. Usually, if you increase the depth to 6 to 7 to 8 to 9, what will happen? Tell me. If you have a decision tree, 6 is kind of giving you optimal, but you picked 7 or 8 or 9 or 10. What will happen in general, in reality? That should lead to overfitting. But why am I suggesting 9 to 10 as a decision tree, single decision tree in the random forest? You go 50% above this decision tree. That's what I'm saying. Why am I saying that? Why I'm not worried about overfitting here? How many columns this decision tree is using? How many columns?
22.
22.
How many columns these decision trees are using in random forest? Are they using
5 to
22
7.
columns? 5 to 7. If you are using only 5 to 7 out of 22 columns, is it okay if you go slightly deeper? Think about it.
Yes, sir.
Are we really having a risk of overfitting here? There is no such risk, isn't it? Once again, listen to the logic. What is the logic? Usually, if you increase the depth of the decision tree, overfitting happens. But here, I am intentionally increasing the depth. The reason is I'm using max to max 5 to 7 columns. That is very, very less. 5 to 7 columns are too few for overfitting. That's why you can increase the depth. But that doesn't mean you can take very high. If you increase the depth too much, then also overfitting will happen. That's why 50% more than the decision tree. So if you follow these tricks, these are not rules. These are some of the tricks that are observed after working on several problem statements. These are not rules set by anybody. So the parameter that is in the code is the number of trees are given as n underscore estimators. That has to be a very large number. The number of features are given as max underscore features. Max depth is given as max underscore depth only. If you choose this correctly, if you choose this correctly, if you choose this correctly, then overfitting may happen, underfitting may happen. Check the train and test accuracy. Keep on picking them. Once you have the maximum accuracy on train data, matching accuracy on test data, then you will finalize that. The optimal values are range of values. There can be multiple solutions that will lead to the same accuracy. So what I want you to do in this classroom right now is all of you must try different trees, different features in the given range. Try this range, try this range, try this range. Once you have the highest accuracy on train data, matching accuracy on test data, in the chat window, put 5 numbers. Otherwise, it will be confusing. Exactly put a message with 5 numbers: trees, features, depth, train accuracy, test accuracy. Go ahead. Once you can beat this 85, 86, once you have a better model than decision tree, give that result in exactly 5 words in the chat window. Go ahead. All of you, give your result in 5 words in the chat window. Then I'll write it down here. Try different trees, features, depth. For that, train accuracy, test accuracy. Let me write down one by one and see what are the suggestions, what are the changes that we can make. Don't put all the confusion metrics and all that. Just for avoiding all these issues, just put exactly 5 words in the chat window, nothing else. Let us take Abdul's result. Number of trees k equal to 100. That's a good number. It has to be larger. Very good. Max depth D is 8. It would have been even better if it is slightly higher, maybe 9 or 10. Max features 5. That should be fine. Even 6 or 7 is also fine. So you got the train accuracy to be 80, test accuracy to be 88. So what I suggest is, it's good. Maybe if you try something like 9 or 10, there is a scope that you can even improve this. Okay. This 5 can be left as it is, or even you can try 6 or 7. So basically, surrounding, if there is even a little bit improvement we can see, then we can try that. So try these numbers, see whether you can improve that. Okay. Ritik Shah. N estimate is 250, not bad. It's safe to be giving us a higher value. Max feature 7, that is not bad. Max depth 10. This looks good. This also looks good. This also looks good to be very near to the optimal values. Train accuracy happens to be 92. Test accuracy happens to be 90. Generally 1 or 2% is allowed. Anything more than that is considered as overfitting. This looks almost perfect. No need of changing anything in that. Jagannath. Number of estimators 20. Now that is too less. What is the usual number that we have to try? Isn't it? 50 to 300. It has to be very high. Okay. Max features 5, not bad. And then max depth 7. Now that is too close to this one. So usually it has to be 50% more than the original decision tree. Maybe this one try something near to 100. This one try something near to 10. Then definitely you will get better accuracy than I think somewhere around 87, 86. This is also not bad, but there is a scope for improvement in this. Okay. Next one. Tariq. That is a message that I'm looking for, exactly 5 words, which is number of trees, number of features, max depth. Good, not bad, good, 92, 90, perfect. Yes, Shashvi. N estimator 270, very good. Max features 4, okay, okay. Max depth 6, very bad. What is the result? I'm just guessing somewhere around 86 or 87, 86, somewhere around that, or 85, 86, somewhere around that. So what is the next action point? Try something to be 6 or 7. Definitely try something to be 86, 85. 86, 85 is as good as your decision tree. Decision tree with single tree you're getting 85. With 270 trees also 86, 85. That because of this depth, make it somewhat around 10. Maybe try 6 or 7. You will be able to fix this. Now you have fixed it, Jagannath, which is like 250, 7, and 10. So that will be 92, 90. So what I'm trying to say is this option of 90 to 90 comes for different set of parameters, hyperparameters are giving you the same result. The right option is not just single one. There can be multiple solutions that are leading to this. The last one I'll write down from Arun. 30 trees, too small. What is the suggested number? When you're building the random forest, make sure the number of trees have to be very high. Try a number between 50 to 300. Max features 5, that is not bad. Max depth 7, now this is bad. Max depth has to be 50% more than a single decision tree. Try a number as 9 or 10. Right now you're getting 87, 86. The model has the scope for 90 to 90. Okay. Everybody in the classroom must get 90% accuracy on the test data. You have to keep on fine tuning until that point because that much scope is there. Have you understood this process, all of you? Will you be able to fine tune with these tricks? Generally, this trick works for most of the problems, but for a given problem, you may have to search somewhere beyond this. Nowadays, there are several automated packages, algorithms that are taking care of this, but it's good to know our own methodology of fine tuning. Right? Any questions on this, anybody? So in conclusion, what I want to say is, one of the questions that I received was, random forest is always giving you 2 to 3% lift than decision tree. In fact, this was one of the interview question. Okay. Actually, in the interview, that question was asked. A student could not able to answer. Then he came to me and he asked this question. Random forest is giving 2 to 3% lift in the accuracy always. Sometimes it is giving you 5% lift also. Then why do we still use decision trees in the industry? Why do still decision trees exist? Why can't we work with random forest everywhere? That was the question. Have you understood the question, all of you? Simple logical question, isn't it? If random forests are giving you better accuracy than decision tree, why do you still use decision tree? Why can't we simply use random forest? Can you think of an answer for this? What is the answer?
Maybe due to the cost involvement.
Yeah, there can be several factors. The first factor is random forest calculation intensity wise. Which one requires more calculation power? This is calculation intensive. Yes or no? It also processing time. Which one takes more processing time?
Random forest.
This takes more processing time. Sometimes you may have to give the result quickly. Yes or no? Let's say when you swipe the card, as soon as you swipe the card, behind the scenes, the fraud recognition algorithm has to run, and very quickly it has to give you a prediction whether it is a fraud transaction or not. Yes or no? Let's say if you swipe your card, will you wait for 2 minutes for getting the prediction that yes, this can be a fraud transaction, or you want it under seconds? Tell me. Fraction of second, the model has to run, isn't it? The user should not even feel that there was a model that was running. Yes or no? And at a single point of time, millions and millions of transactions are going to happen. Do you think you have to understand every transaction and find out the fraud, or only a random sample of 5-10 records per day, 5-10 transactions per day, you have to predict the fraud? Tell me. We have no option, isn't it? Every transaction we have to predict whether it's fraudulent or not. Okay. Processing power need to be fast. Okay. Now, in decision tree, we could give variable importance. In decision tree, we can tell which variable entered the decision tree, which variable did not enter the decision tree. You can draw the decision tree and show it, interpret it. Yes or no? Have we drawn the decision tree? Have we interpreted it? Have we told that which customer will be a buyer, which customer will be a non-buyer? What is the variable that is entering? Is it possible to draw the decision tree, interpret and explain it to a layman? Show what's happening in the decision tree?
Yes, sir.
Similarly, can you draw the decision tree? Can you interpret it? Can you draw the random forest and interpret?
No.
Can you show it to anybody? Is it that simple? No. Interpretation is impossible. Random forest is a black box method. What do you mean by black box? What happens inside the random forest? Is it that easy to comprehend and see? What's happening inside random forest? You will not be able to see what is happening inside that. There is no way you can find out. Like, it's almost like a black box, but it gives you better accuracy. Another important issue with the random forest is in decision tree, finally you will get customer segments as the output. Yes or no? If you want to do marketing segmentation, decision tree apart from prediction, what does it give? It will give you customer segments as output. We apply strategy 1 on segment 1, strategy 2 on segment 2, strategy 3, strategy 4. Random forest, does it give you segments like this so that you can apply one strategy on each of the segment? Does it give you 4, 5 or 6 segments like this? If you want to do customer segmentation, okay, you want to run marketing strategy or sales strategy, sales segmentation, customer segmentation, you have two options. Would you go for random forest or decision tree? Which one will give you the segments? Decision tree. So what I'm trying to say is random forest is giving you better accuracy. That's an advantage. But is better accuracy is the only criteria that we always look for in every problem statement? Or are there any problem statement where we are okay with lesser accuracy, but we want interpretation power? Where we are okay with less accuracy, where we want the problem to be solved? That is why which algorithm to choose always depends on, what does it depends on?
Business problem.
Business problem. What is the myth that is running outside? People think that which algorithm choose depends on the data type. Have you seen these kind of lectures? Some people will say, if the data type is numeric, go for this algorithm. If it is kind of categorical, go for this. Does it really depend on data type? Not really. You have to solve a business problem. Whichever is the best suitable for that business problem, you go with that. Imagine you are building a model that will predict whether a customer is a good customer or a bad customer before giving a loan. Let's say you built logistic regression. You built logistic regression versus you built a random forest. With logistic regression, you predicted whether a customer is a good customer or bad customer. You got 90% accuracy or 88 only. With random forest, you got 92% accuracy. Now these models that you have built that will predict whether a customer is good or bad customer, these are credit scoring models. Now, as a bank, can you directly reject a customer saying that he's a bad customer, or you have to show your credit scoring model to the regulatory authorities? Can you run the models directly, or do you need to show these models to regulatory authorities and get an approval? Tell me. Especially credit scoring models, you have to show them to regulatory authorities. You have to, because we have to follow certain rules, isn't it? You cannot just give the loans to all your relatives and reject the loans applications of all the people that you don't know. Yes or no? These credit scoring models need to be transparent. We need to get approval from regulatory authorities. You cannot use some variables. Can you use customer location as a variable? Customers from a particular location, they are all bad customers. Can you use that in your model? Can you discriminate people based on their place, based on their race, based on gender? Can you use gender male, female in a credit risk model? Have you seen that anytime?
Nope.
You're not supposed to discriminate people based on those factors, isn't it? What if you're doing that? Will they approve your model? If you're doing any wrong things and you're giving only loans to a certain kind of customers, the regulatory authorities in the US say that is known as OCC guidelines. In India, RBI guidelines. RBI guidelines ke anusar, like you might have seen such messages, isn't it? Now you have logistic regression model, which is giving you 88% accuracy. You take this to regulatory guys. Can you explain the variable impact? Whether a variable is positively impacting, negatively impacting on the target variable Y. Can you do that in logistic regression? Tell me. Whether a variable is
Yes, sir.
impactful or not. Can you do that in logistic regression?
Yes, sir.
Yes.
Can you very simply show your logistic regression, what variables are there, what weightage is there? Can you show that? The relationship of X versus Y, isn't that easy to show? Very easy. So you can easily explain this to regulatory guys. Now you take the random forest model, which is higher accuracy, 92% accuracy. You will be able to make better predictions. But if they ask you the question, this particular variable Xi, what is the impact on Y? Can you explain it? Whether it has a positive impact, negative impact on the target, can you explain it? Are you doing any variable selection? Are you using all variables? I'm using all variables. Now, do you think they will approve this model of random forest that you have built because you are saying that I cannot answer your questions? It is a black box model. It will take the input. It will give you the output. Which model will get approval? A model with 88% accuracy, explanation power versus model with 92% accuracy, black box method. Which one will get the approval from the regulatory guys? Tell me.
Logistic regression.
Logistic
regression.
If they don't understand this model, do they approve it? Do they even put some effort to listen to you? What do you think? The regulatory people are those government guys. Yes or no? They don't pay any attention. It has to be simple. That is why even though logistic regression is having lesser accuracy than random forest, even though logistic regression is having lesser accuracy than several other complex machine learning models, this is the one that is still used today. When somebody says I'm working on credit risk model, what is the model that is used nowadays also?
Logistic regression.
Logistic regression. The project that you are working on, for the sake of practice, you will build random forest. But if in the interview they ask you, which is the model that you have built finally, what will be your answer? Which model have you built?
Logistic regression.
Logistic regression only. Okay. Maybe just for internal benchmarking, just for internal checking, we may have tried random forest. Logistic regression, even decision tree is also fine. These are simple models, but they are more explanatory power. These are complex models, but less explanatory power. Now, will you be able to answer that question? Why do still we use simple models if there is random forest? All these points are clear to you?
Yes, sir.
That is the story of random forest.